So we have just received LLaMA 4 from Meta. Now the reason I'm doing this video, not only to explain technically how it works based on their documentation online, but also I've seen that the model is not getting the attention it deserves. Some people soon also will start testing this model against other models, but it's not about that. I actually am an advocate of Meta. I never thought the day would come where I find myself advocating for Facebook and Meta. But when it comes to AI and having their models open source, that's a big thing for the AI community. Now, one of the great things when we get a new LLaMA model, because it's open source, we can actually look into it, sort of, and then try to understand what they did differently, at least read what they explained to us, what they tried to do to make it as good as it is when it's dropped, and then benchmark that to the closed source models. Because if Meta is doing something at a certain level, others probably are not doing something out of this world. So it should be around the lines of what Meta is doing and exposing to us. And again, I think I'm clear on that in my videos. I'm on the camp of open source AI. So I will always root for anyone who is open sourcing their AI, including Meta and the LLaMA models. And don't forget, like the video, hit the subscribe button if you enjoy it as you are watching it. And with this, let's get started.
Subscribe to Daddy's channel, the mic.
So I will take you through the official LLaMA 4 announcement with how they've built it, the technical details of it. I will try to go as fast as possible. There are terms and things that I will not cover, but as usual, you will find in the description all the links that you need if you want to read more into any of these concepts. And with this, we'll start with the title. The LLaMA 4 Herd, the beginning of a new era of natively multimodal AI innovation. So they're calling the LLaMA 4 as Herd, and we'll understand now why is that. So this is the Herd. So you have this image. So LLaMA 4, leading multimodal intelligence, newest model suite offering unrivaled speed and efficiency. And they have basically three models here. They have LLaMA 4 Behemoth, which is a 288 billion active parameters over 16 experts. So they're using mixture of experts, clearly, like DeepSeek models and other models that deploy that. And it is a 2 trillion total parameter model. That's a huge model. Now, why this is significant? Because they're dropping this model with 2 trillion parameter. When we got GPT 4.5 from OpenAI, it was all rumored that that model is multi-trillion type of model. Some people even were saying it's somewhere between 5 to 12 trillion. I'm not sure of the accuracy of these insights. I'm not an expert, so sometimes I just take what I hear and I keep such information in the back of my head with some skepticism. But when we get something like this, the LLaMA 4 saying that their Behemoth model, which by the way is not out yet, is trained on 2 trillion parameters, then I would question the numbers that people are saying around GPT 4.5. And then they have the LLaMA 4 Maverick, which is a 17 billion active parameters over 128 experts and 400 billion total parameters. And this is the interesting thing about the LLaMA 4 models. It has a native multimodal with 1 million context length. So this is actually competing with what Google Gemini is offering in the market today to a certain extent. But this is the big one here. So the smallest model they are offering, which is out today, LLaMA 4 Scout, it's a 17 billion active parameter over 16 experts with a total of 109 billion total parameters. So it's a mini type of model. And it has an industry leading 10 million context length optimized inference. 10 million context length optimized inference, just to be clear there. So they explain how they did that. And this is a game changer when it comes to coding. The biggest challenge when people vibe code using AI is they hit those limits when it comes to context, and then the model starts going sideways. So this is something I cannot judge now in terms of how it will operate, but it's definitely something interesting to play with and experiment. And I know the People who review coding on these models will definitely go there and stress test it for LLaMA. Let's just quickly go over the main takeaways that they are sharing with us about their models. So here they're saying that their models will enable more people to do more things, and obviously what they're highlighting for their models being multimodal experiences. Okay, so LLaMA 4 Scout, a 17 billion active parameter model with 16 experts, which we've read already, is the best multimodal model in world in its class and is more powerful than all previous generations of LLaMA models while fitting in a single NVIDIA H100 GPU. Additionally, LLaMA 4 Scout offers industry-leading context window of 10 million and delivers better results than Gamma 3, Gemini 2.0 flashlight, and Mistral 3.1 across a broad range of widely reported benchmarks. Okay, so this is just about the smallest model they have. Now, when it comes to Maverick, a 17 billion active parameter model with 128 experts is the best multimodal model in its class, beating GPT-4o, Gemini 2.0 Flash across a broad range of widely reported benchmarks, while achieving comparable results to the new DeepSeek V3, which is V3.1 I assume, on reasoning and coding at less than half the active parameters. LLaMA 4 Maverick offers the best-in-class performance to cost ratio with an experimental chat version scoring ELO of 1417 on the LM Arena. So if we go and I'll give you the link for this this basically dashboard where people vote for the models, and you can see already after the LLaMA 4 being dropped, LLaMA 4 Maverick here is ranked at number 2, just after the new Gemini 2.5 Pro and on top of the ChatGPT 4o latest model that we have. And you can see here is the arena score, and you can see here are the votes and then other information. So I'll put the link, you can check this out and look into it yourself. Okay, and then they're saying that these models are our best yet thanks to Distillation from LLaMA 4 Behemoth, a 288 billion active parameter model with 16 experts that is our most powerful yet and among the world's smartest large language models. LLaMA 4 Behemoth outperforms GPT 4.5, Claude Sonnet 3.7 and Gemini 2.0 Pro on several STEM benchmarks. LLaMA 4 Behemoth is still training, and we are excited to share more details about it even while it's still in flight. So this is the preview part of it. They're going to give a preview to it. It's still being trained, and what they claim, it's already better than GPT 4.5 and Gemini 2.0 Pro. So that's a big claim to make. And they use it as a kind of a teacher model, and then they use it as a big model that they distill to these smaller models that today we have access to, like the Scout and Maverick. Let's carry on for the important parts that I think differentiate LLaMA 4 from other models, but also confirm our understanding where the industry is today when it comes to developing these AI models. So here in this part, they're just telling you how great the LLaMA ecosystem is, and then they follow that with how optimized and efficient these smaller LLaMA models are, and how you can, for the Scout, fully run it on an H100 GPU with, and the Maverick actually you can fit on a H100 GPU with Intel 4 quantization. And also here they confirm, if you see this point, that they are training the teacher model. So the LLaMA 4 Behemoth that outperform, so they repeat that it outperforms Sonnet 3.7, GPT 4.5 and Gemini 2.0 on STEM focused benchmarks, yada yada. Okay, they just confirmed that they're still releasing the preview of it, and this is the teacher model for these smaller models. So let's go to the actual idea of how they made these models that apparently claim to be better than the competing closed source models out there today, and what they employed in terms of training model technology, inference technology to make them efficient, and something that now they're pushing as best-in-class open source models. So let's start with the pre-training. And I have a playlist when it comes to reviewing these AI papers and ideas. And you can go to see all of these concepts if you want to understand about them. I've reviewed them, covered them in previous papers. But pre-training now in today's world, we give our models, we take them through a pre-training process or phase where we give them unlabeled data, basically a huge chunk of text, a huge chunk of image or video, whatever the mode of the model you're training is, and we get it to try to understand that on its own. And eventually you don't get the best level model, so you get that kind of base model, but it's not super dependable in terms of actually taking it out to the world. But you have the elements of a model that can be later on fine-tuned and trained further to be super smart in interacting with people. But what this pre-training method does, it actually gets the model to act more closely to how humans think. So it goes into that unlabeled information it's dumped with. Text, for example, tries to understand it, tries to reason with it, and eventually, while it's not perfect, it gets lots of benefits just by going through that pre-training model, rather than the older way of doing things where we used to fine-tune each model for a specific use case, which wasn't reasonable and practical for all these AI companies, because you hit two major challenges if you do that. Number one, it takes lots of computing, lots of actual preparation and processing to do each use case and train it that way. But the other one is the effort that has to go in preparing the data for each time you do that. So now we're not doing that anymore. And this again confirms that I assume also ChatGPT and Sonnet or Claude, they all go through this pre-training process. So let's quickly read about that and see what they've done there. And again, this is the same what DeepSeek V3 did, and you can watch my video around that in detail. These models represent the best of LLaMA, offering multimodal intelligence at a compelling price while outperforming models of significantly large sizes. Building the next generation of LLaMA models require us to take several new approaches during pre-training. So the first one is the mixture of experts. Now, all of this is nothing new. These are existing technologies that many companies or basically AI models are already employing. So in mixture of experts models, a single token activates only a fraction of the total parameters. Mixture of expert architectures are more compute efficient for training and inference, and given a fixed training flops budget, delivers higher quality compared to a dense model. So flops, by the way, is just a rate of the speed per second of certain bits that go through the model. Just something that could give an indicator about the computing requirement of the model or the consumption of the model. So you can look it up, but just understand it this way because it's going to be mentioned multiple times during this video. Now, if you look at the mixture of experts, the way you can think of it, if you have 100 billion parameter model and you employ a mixture of experts, you don't want each token actually to go through that huge feed-forward network every time, and which will take lots of computing. What you want to do is, and this is not a new idea, you create what they call an expert. And an expert, basically, it's a cluster of parameters within that model. So let's say we have 100 billion parameter model and we have 10 of 10 billion parameter each experts. So 10 experts of 10 billion of a total of 100 billion parameter model. And when the token goes, it goes actually through two experts. There's always a shared expert that you can see here on the image. And then there's one of the other experts that it has to go through. All happens through math. When the token goes in, it will activate one of those experts. Usually there's a switching mechanism. And this is, again, something complex, but this is the easiest way to understand it. It goes to one of the experts and then goes back to the end of the network and goes back to the second attention cycle. So you can see here they're showing you that this is only what happens in one stage of it. And this usually happens in training, not in inference, I assume. So you get the attention calculations, then the feed-forward network, attention, feed-forward network. So it goes in cycles as it's being trained. I think in inference it's not like that. It doesn't happen in cycles this way. So this is the first big thing, using the mixture of experts. Now here you can read all about it. They're just telling you how this helped them actually to run these models, the smaller models, on a single H100 NVIDIA GPU. Now, one more thing which is really interesting in what they've done here to train these models is that they actually, what they claim is they developed a new training technique which we refer to as MetaP. So they call it MetaP, this technique, that allows us to reliably set critical model hyperparameters such as per layer learning rates and initialization scales. We found that chosen hyperparameter transfer well across different values of batch size, model width, depth, and training tokens. So they're per layer, they're changing these hyperparameters for the model. So that's interesting. It's an idea I've never heard, or I never knew that it's possible before. LLaMA 4 enables open source fine-tuning efforts by pre-training on 200 languages, including over 100 with over 1 billion tokens each, and overall 10x more multilingual tokens than LLaMA 3. Okay, so that's interesting. They changed these hyperparameters per layer. Apparently that's yielding great results, and also they confirm the fact that actually they have open source fine-tuning, which is a well-known fact, but again here it's done better and it offers more capabilities potentially than what we got with LLaMA 3. Also here what they tell us is that additionally we focus on efficient model training by using the FP8 precision. So FP8 again is something that DeepSeek v3 brought forward. It's not, again, nothing new, but when you do the calculations within the model, they use an 8-bit calculation where most heavy calculations are happening on 32 bits. But if you do everything on 32 bits across training the model, it becomes expensive computationally, and it has more requirement, obviously, because you have 3 times or 4 times the bitrate. Now, what they've done in DeepSeek v3 at that time, they said there's so many calculations that happen within the model that are not necessary to run with 32-bit. So what they've done is they ran most of these calculations with FP8, which is based on 8-bit, and then where it matters, like attention, actually they deploy the 32-bit calculations only there. So, and this happens without, again, sacrificing quality and ensuring high model flops utilization. So again, flops. So this is an efficient way of doing things. While pre-training our LLaMA 4 Behemoth model using FP8 and 32K GPUs, we achieved 390 T-flops per GPU. This is again a rate per second, okay? The overall data mixture of training consisted of more than 30 trillion tokens, which is more than double the LLaMA 3 pre-training mixture and includes diverse text, image, and video datasets. So basically, it was trained with a huge amount of data. So you can see here, it's a 30 trillion token that is used there. But just by leveraging the FP8 precision model, actually it got them to do it really efficiently. I don't know, like the 39 T-flops per GPU, if it's a good number or not. Honestly, I can research it, but I know for a fact from what they're saying and from what we've read into the DeepSeek paper that just employing the FP8 precision as part of your model, you do save a lot of computational requirements. Okay, so let's go to the post-training of the model. So now we have pre-trained the model. It's ready to do more magic when it comes to supervised fine-tuning, reinforcement learning. And this is the phase where you actually get the model public ready and high quality ready. So this is what they take the model through now to put it forward to the public and to show them. So the first phase is important, but definitely this phase is super important in terms of the quality when people experience when they are inferencing with these models. Okay, so let's read the main thing they put around post-training. So the biggest challenge while post-training the LLaMA 4 Maverick model was maintaining a balance between multiple input modalities, reasoning, and conversational abilities. For mixing modalities, we came up with a carefully curated curriculum strategy that does not trade off performance compared to the individual modality expert models. With LLaMA 4, we revamped our post-training pipeline by adopting a different approach. So basically, when you do these and train these multimodal kind of models, it's challenging because you're not dealing with the same nature of data. So you're dealing with text, you're dealing with reasoning, video, audio. So it's easy to get the model to get confused, basically. I think that's the right way to do it. So they changed what they call the curriculum strategy of training the model, and they employed a different method that helped them actually get high quality outputs just by putting and training all of those different aspects of a multimodal model through or what they've done here in LLaMA 4. So what they've done, and again, this is super familiar, by the way. So they've done what they call, and you can see it here, a lightweight supervised fine-tuning, and then they go to an online reinforcement learning, and then they do a lightweight direct performance optimization. Again, my previous videos cover these concepts, but in very quick sentences. When we do supervised fine-tuning, we basically give label type of data to the model to fine-tune itself from the pre-training that is already done. Sometimes you do that with multiple kind of examples or a single example. Sometimes those are reasoning complex examples. So depending on the model and what they try to do. But basically we give it some kind of, this is an input, this is an output, in the easiest sense of it, as an example, and we ask the model to fine-tune. And then we go to reinforcement learning at the second phase here of post-training. And here, basically, we give it a goal. We tell the model that this is, we want you to reinforce, learn as a model to achieve this outcome. That outcome could be a human feedback provided, or that outcome could be kind of a target or a result that is driven by calculations that the model is enabled with. And in this case, there would be a reward system where the model's job as its reinforcement learning as a model is trying to get these rewards. So that's in a nutshell. And lastly, we do something called direct preference optimization, which is a pure systematic type of reinforcement replacement to reinforcement learning with human feedback. And it is a kind of an algorithm, a learning algorithm that helps the model get human preferences just by looking at the unlabeled data and the pre-trained data of the model. And this is something, again, DeepSeek v3 deployed, which was big news when DeepSeek v3 went out and they employed this method, and people were saying this is one of the reasons actually the model was as good as people experienced it just because of using this direct preference optimization methodology. Again, I'll put a link for all of these concepts, or at least the DPO in this case, for you to read more about it. Now, interestingly, they mention here a key learning was that supervised fine-tuning and DPO can over-constrain the model, restricting exploration during the online reinforcement learning stage and leading to suboptimal accuracy, particularly in reasoning, coding, and math domains. To address this, we removed more than 50% of our data tagged as easy by using LLaMA models as a judge, and did lightweight supervised fine-tuning on the remaining harder set. Okay, carrying on. They say, furthermore, we implemented a continuous online reinforcement learning strategy where we alternated between training the model and then using it to continually filter and retain only medium to hard difficulty prompts. So again, apparently the easy prompts are actually detrimental to the model. So they're not helping the model, they're harming it, or the performance or the quality. This strategy provided highly beneficial in terms of compute and accuracy trade-offs. We then did a lightweight DPO to handle corner cases related to model response quality, effectively achieving a good balance between the model's intelligence and conversational abilities. Both the pipeline architecture and the continuous online reinforcement learning strategy with adaptive data filtering culminated in an industry-leading general-purpose chat model with state-of-the-art intelligence and image understanding capabilities. So this is complex to just saying they played with the data they used in the reinforcement learning, the DPO, and the supervised fine-tuning in a way that balances intelligence with conversational abilities and compute with accuracy trade-offs. So that's an interesting take. Now, if you know more about that, please do not hesitate and write a comment in the comment section, not only for me, but for the community. Maybe we can definite more if you're an expert in these areas and how significant this is what they're doing here. But so far, it just is telling me that they are not far off from what DeepSeek are doing in terms of the technicalities of training and developing the model. Maybe they have better data, but the way they're doing it, it's not far off from DeepSeek. Again, this gives us a point of reference of what other models are apparently doing as well. So yes, GPTs could be better in certain models, and Sonnet in coding, for example. I do not believe they will be doing their training of their model way far off from what we're reading here. Now, let's read this part. A general purpose large language model, large 4 Maverick, contains 17 billion active parameters, 128 experts, and 400 billion total parameters, offering high quality at lower price compared to LLaMA 3.3 70 billion parameter. So it's cheaper than the 3.3 70 billion version of the model. LLaMA for Maverick is the best in class multimodal model, exceeding comparable models like GPT-4o and Gemini. Okay, so they're repeating the benefits of this model. It's cheaper, it's better, it's even better than the competitors out there right now. And here they just take you through some of the benchmarks. Now remember, this is a 400 total billion parameter model, so when you compare it, you should also compare it to models that make sense to benchmark against. So here they have it against the Gemini 2.0 Flash, DeepSeek version 3.1, and then GPT-4o. Now we know DeepSeek version 3.1 is 600 plus billion parameter, so it's a bigger model, somehow not so much bigger, but it's definitely bigger. We don't know obviously about the Gemini 2.0 and GPT-4o. And then here they're just talking about the cost, so it's definitely cheap and competitive. Still apparently more expensive than the Gemini 2.0 Flash, and it's doing really well against benchmarks. Again, you can come and read this kind of benchmark in the links. It is making its own path or own place in these newer models by all of these AI companies. So that's very clear here. So let's carry on with what's important for us to really grasp. Did they do anything different in getting the LLaMA 4 out there and having it so efficient and so strong and smart as a model? At least taking their word for the performance of these models. I'm sure people will start testing and either confirming or actually questioning the claims of Meta here. Now here they're talking about the context. So we have 1 million context for the Maverick, and for the Scout 10 million. And again, this is interesting because, yeah, we know Gemini can deliver it. We do not know really how, at least I never thought about it. How would they achieve such a thing? I always questioned if it's there's a trade-off between that context and the quality of the model. So let's read here. It gives us an insight to how they look at this as a AI company, AI business. Now, more people, when they look in the details of the model, once they download it, might come up with new insights into what they're doing to really achieve that. So let me read here. LLaMA 4 Scout is both pre-trained and post-trained with a 256,000 context length, which empowers the base model with advanced length generalization capability. Okay, so here we present the compelling results in tasks such as retrieval with retrieval needle in a haystack for text, as well as cumulative negative log likelihoods NLLs over 10 million tokens of code. So this is impressive. The first one tells us, is it good at retrieving information? And the second one tells us, within all of that context, was the process of training that model optimized? Is it efficient? And I think this is a cost parameter, at least what they are addressing here, which is the negative log likelihoods NLLs. And this is a way to judge how the model is operating based on all of these kind of specifics that they want to deploy with the model, especially with a huge context window. Now here is the important note. A key innovation in the LLaMA 4 architecture is the use of interleaved attention layers without positional embeddings. Additionally, we employ inference time temperature scaling of attention to enhance length generalization. We call it the IROP architecture, where I stands for interleaved attention layers, highlighting the long-term goal of supporting infinite context length. The ROP refers to the rotary position embedding employed in most layers. So here in this small couple of sentences, they are referring to at least 2 or 3 papers that I've put my hands on. I'll share the links of those papers with you if it actually is something you're interested into reading and trying to understand. I think those things are really nice to read when you have the time. I will not cover them here. I might read them on my own time. But fundamentally, all of these are innovations in the world of AI. One of them, when it comes to actually the importance and efficiency or added value of having the positional encoding. So when we go in a transformer, actually part we get the embedding and other part is the positional encoding of the token that we are looking at. They question that this just adds to the problem, not actually solves something, so it has no value. So there's a whole paper around it, where it can be used, where it shouldn't be used. And the other one is just focusing in a different way of handling the softmax function within the transformer. Again, I didn't read the paper, but they call it a scalable. They're offering a scalable softmax, which handles things differently. And again, this is something that eventually is enabling a model potentially to handle a huge context at high quality performance. And they took the knowledge of or the innovation in these 2 papers, they employed it here to be able to give us the LLaMA 4 Scout with 10 million token context and the Maverick, which is a much bigger model, with 1 million context. So clearly, if we want to learn from this, it seems the Gemini models, if we're benchmarking, they play within the transformer itself and the actual elements it looks for to calculate the attention. So they're taking out the typical way of thinking about these positional encoding or embeddings for the tokens coming in. And also they're playing with the softmax. So they're doing it differently to scale it in terms of what they call the rotary position embeddings that potentially are enabling huge context at the same quality of operation. These are interesting. I will probably read these papers myself or scan them at least, but I recommend the same for you. If we carry on here, you can see here this is the needle in a haystack testing, where they see the quality of retrieval augmented generation of these models. And you can see the blue box is a successful retrieval, the white box is a failure to retrieve, and you can see LLaMA 4 Maverick test, pretty much an A. LLaMA 4 Scout and then LLaMA 4 Scout. This is different kind of testing criteria. You can see the details here. But basically these models are operating at a really high quality when it comes to retrieval at these contexts. And then here you can see this cumulative average NLL for code, which is basically a cost parameter as I explained. And you can see as the training goes on, this keeps reducing, meaning that the model efficiency and optimization is very high even at these kind of large context windows. So that's just to showcase that whatever methodology they employed is proven that it is working at high performance and high quality for their models. Again, this part they're focusing on video and audio, and they're just talking about that it was trained well in these kind of modes of an AI model, but they don't really dig deep in here. Again, in the future, I think as this gets rolled out, we're going to have more and more details about the specifics and what goes under the hood in more detail. Here they go for the LLaMA 4 Scout instruction tuned benchmarks. Again, here you can compare it to smaller models. You can see comparable models, I would say. You can read this at your own pace, but definitely it's a model that will make noise in the world of AI. Again, remember, this is an open source model that you can put on a single H100 GPU. That's a big deal if you're running a business or you're running an institute where you want your own on-premise model to do with it whatever you wish to do, especially that this is an open weight model as well. Now, moving to the last part of this video is actually talking about the teacher model, the Behemoth, that is a 2 trillion parameter model. So pushing LLaMA to new sizes, the 2 trillion Behemoth. So they're talking about it here, and they're saying, we are excited to share a preview of LLaMA for Behemoth, a teacher model that demonstrates advanced intelligence among models in its class. LLaMA for Behemoth is also a multimodal mixture of experts model with 288 billion active parameters, over 16 experts, and nearly 2 trillion total parameters, offering state-of-the-art performance for non-reasoning models on math, multilinguality, and image benchmarks. It was the perfect choice to teach the smaller LLaMA 4 models. We co-distilled the LLaMA 4 Maverick model from LLaMA 4 Maverick Behemoth as a teacher model. So these are distillation models fundamentally, resulting in substantial quality improvements across end task evaluation metrics. We developed a novel distillation loss function that dynamically weights the soft and hard targets through training. So again, they innovated in the distillation process of the Behemoth model to get the Maverick model here. Co-distilling from LLaMA 4 Behemoth during pre-training amortizes the computational cost of resource-intensive forward passes needed to compute the targets for distillation for the majority of the training data used in student training. For additional new data incorporated in student training, we ran forward passes on the Behemoth model to create distillation targets. So the Behemoth is actually where everything happens. The Maverick and the Scout are distillations or used or improved with data generated from the Behemoth model. And again, here they benchmark it against the big players. So you can see Claude Sonnet 3.7, Gemini 2.0 Pro. It will be interesting to benchmark it against the 2.5, and then GPT 4.5 here. And you can see definitely it's a model that will make a lot of noise when it comes out. We don't have it yet. We have a preview, and I do not think preview will be accessible even to everyone, to the public. And anyways, it's a huge model. So I would say only their partners who are corporates and organizations will be able to run the Behemoth model. And here they close with talking more about the repeating some of the points, actually the same what happened with the Maverick and with Scout, on how they trained it through supervised fine-tuning, reinforcement learning, DPO, all these kind of methodologies. And then they repeat that they scaled this down to these distilled models that we have access to today. And there are some topic on safety here, which is an important aspect in AI. Now, they don't focus on it as the focus OpenAI gives to safety and red teaming. So here you have it, folks. In general, you should be understanding how the LLaMA 4 model works from a technical perspective. I am a proponent of open source models. I appreciate what a company like Meta and LLaMA is doing for the AI community. I do not think it's out of an open heart and good faith. They have a business target behind this, probably to disrupt the market or control the market, because in my opinion, people will gravitate more to open source models as those become smarter, better, lighter weight to operate. But again, the most important thing for me is to benchmark based on LLaMA on what's happening out there, because when you deal with the closed source models, really we don't understand what they're doing. But I would bet my money that whatever they're doing is not like light years ahead of what LLaMA does. Again, we're dealing with Meta here. They are a big player, and maybe in certain areas they're actually leading the way. So what we are getting from OpenAI and Anthropic and Google will not be way different from what actually LLaMA is doing in developing their models, which tells us that most of these companies are going down the same path when it comes to how do you train a model, how do you fine tune it, how do you actually get it to perform, how do you optimize for computational versus quality, accuracy, conversational ability. All of these things, they just go around the same concepts and technologies. Maybe they play around with the data and other things, but pretty much they're trying to do the same, maybe tuning their models differently to get us different outcomes. But this is the technology that pretty much is the basis of all of these AI models out there. So I hope you enjoyed this video and got some learning out of it. If you found some of it interesting or you have questions, do not forget to write a comment in the comment section, and I'll leave all the links in the descriptions that could help you as you watch the video, or if you want to later on to do some of your own reading and learning. So you'll have all of that in the description. So I hope genuinely that you've learned something new and you got value out of this video. Do not forget to hit that like button, share the video with others if you think it's beneficial for them. And with this, thank you for giving me your attention, and goodbye.
Subscribe to Daddy's channel. Give me the mic.